Hello everyone, I'm Sawsan from the University of Oxford, and today we'll talk about my journey so far with carbon-aware networks. To meet the net zero goals by 2050, all sectors are trying to reduce their carbon emissions. Transportation, agriculture, energy sector, and so on, all are trying to improve their productivity and resource use efficiency. And as we know, a big part of this improvement is through automation, which is mainly relying on the internet. So the dependence on the internet is increasing. The infrastructure is expanding. And then a question to ask here really is, what about the carbon footprint of the internet itself? Now, we might have heard of estimates of the carbon footprint of the internet, some overestimates and some underestimates. But the main problem is that we can't improve what we don't measure. The main problem is the lack of accurate derivation tools, the lack of metrics, the lack of standard green solutions, as well as the lack of policy to enforce internet service providers to reduce their carbon emissions. So what we need is to make computer networks carbon aware. We need to introduce carbon awareness to the operation of the internet. So what is this carbon awareness or carbon efficiency? Sometimes it can be confused with energy efficiency. So kind of obvious, if we reduce the energy consumption, then we reduce carbon emissions. Correct. And that is energy efficiency. Whereas if we account for the source of this energy consumed, then we can see that the same amount of energy consumed from renewable energy sources will result in less carbon emissions compared to using fossil fuels. And that is carbon efficiency. So to capture this carbon efficiency, a very important metric here is the carbon intensity, which is the measure of how much carbon is emitted to produce 1 kilowatt hour of energy. This metric varies a lot between regions. As you can see in this figure, this is the carbon intensity in European countries. So the carbon intensity varies a lot per region, but also varies significantly per day and per season. So now back to networks. How can we really benefit from this? One way is placing the equipment in green regions, yes, but another way is through carbon aware routing, which is more dynamic. So now by exposing this carbon intensity information to the routing protocols, packets of information can be routed through greener paths, so through regions with a lower carbon intensity. A big motivation to this approach is the ability to predict this carbon intensity data ahead of time because of new machine learning algorithms, so that is plenty of time ahead for planning. Moreover, this approach has no additional costs because equipment is the same, no change in the infrastructure. It's still the basic routing plan, but we're adding a new metric. So the carbon intensity can be also integrated with existing quality of service metrics. And finally, we simulated this approach and tested it on real network topologies, including GÉANT, and this resulted in an easy 15% carbon savings with negligible impact on user experience. So what are the next steps? And what is the role of every person in this room? For researchers, there are some technical challenges yet to be solved. For example, we need to look at the accuracy and truthfulness of the carbon intensity data from the energy grid. Moreover, we need some standards for the sustainability metrics of networking equipment. It's not just routers. And finally, we need to tie energy and carbon back to the applications or even to users. So one result of this implementation is having standard sustainability indicators for apps and ISPs. And then comes the role of users to pick the greenest internet service provider and the greenest app. For more details about carbon-aware routing, feel free to scan this QR code for the paper that was published last December. And thank you.